Hey guys, welcome back to session 29 of Java Full Stack Made Easy. In previous session, we discussed about the maps. We have discussed the hash table and the hash map. So in this session, we will be talking about the linked hash map and the tree map. So let's get started with that. So this was my previous example where I created a map of players where I have created the keys as their jersey numbers and the names as the value. So it was hash map that I created, and we have already seen the difference between a hash table and hash map. Hash table is thread safe, whereas hash map is not, and the hash table does not allow any null key null values. Hash map does allow that. So that was my last example. So what I will do now is, let's go ahead and create a linked hash map. So I'm creating a linked hash map instead of creating a hash map, right? We will also see what difference will be there in a linked hash map and the hash map. So let's save it, and there we go. Let's save and run it. I'm using an entry set because we have seen that an entry set is better than a key set. So I'm using an entry set. Directly I can get the keys and the values, so which makes it fast comparing to a key set. So now that you notice, the ordering of the elements in which I have added it to the map is maintained. So that's the major difference between a hash map and a linked hash map. Linked hash map is basically a child of hash map itself, but it maintains the ordering. So whenever you want the ordering in a map should be maintained, in that case you will go for a linked hash map. Rest all functionality will be same. And obviously, since I'm instantiating it with a map, then I get only the map implementation methods, not the linked hash map specific methods. So first I will put this into the repository and we will see the other functionalities. So let's go to the repository, and that was day 28. So let's create another repository and call it as day 29. Day 29 demo 1 linked hash map. Fine. So you can also see more differences in linked hash map and hash map. So you can simply type in hash map versus linked hash map, and then you can search for the same. Like we have seen the differences between a key set and the entry set. We can go for a hash map and the linked hash map. As I told you, linked hash map is a child of hash map itself. We have seen that in the hierarchy as well, right? So here we go. Let's see the difference. Tree map, hash map, linked hash map. Only it maintains the orders. Tree map is again sorted one. So we will see that. Let's see a table. Let's find out a table for the same. So here we go. Hash map and the linked hash map. So sorted according to either insertion order or access order as specified during the construction itself. We can specify that. Then null keys, both allows the null keys, hash map as well as the linked hash map implementation. Yeah. Synchronization, not there. If you want synchronization, then you have to go for what? You have to go for a hash table rather than a hash map. All right. So also, yeah, then some linked hash map specific methods are not shown here. So let me go ahead and test that as well. So since I have created a linked hash map out of just a map, I'll change this so that I can get the so that I can get the linked hash map specific methods. Fine. So I'll remove this and I'll create it directly with a linked hash map, because we know that if we create the instance like map and then a linked hash map, I can only call the methods of a map, not the linked hash map. So linked hash map has some specific methods, that is let's say system.out.println the linked hash map players dot, we can go for a first entry that will retrieve us the first player in the list. So I'll just have a system.out.println and get first player. So I can just do a get first entry and I get the first player here. So get first player. Similarly, if you see the other methods available, you can simply say players dot last entry. Okay, and then we have a poll first entry, poll last entry. Poll, we know that we have already discussed. Poll retrieves and removes the element, whereas peek just retrieves the element that we have discussed, right? So we don't have a peek first and peek last, but we have poll first entry, poll last entry. So let's do a poll first entry, and after that let's once again try and print the map. So I can simply say system.out.println, and this is after poll. Let's just print the player directly. Save, run it. So this was my collection before. This was my collection before. Contained 4 elements. I got the first element, get first element, by using a first entry. Then I performed a poll first that retrieved me the first element. Since it is a poll first, it retrieves and removes the element, and because of which now I am left with only the other 3 entries. Like we have this poll first, we have poll last. Like we have first entry, we also have a last entry as well. So these are linked hash map specific methods will be available only either in a linked hash map, or it will also be available into a tree map. Okay, but it will not be available into a hash table, or it will not be available into a hash map, because that does not actually guarantee you the ordering of elements. If the ordering of element is not guaranteed, why would you ever want a first element and a last element, right? So if it is prioritized, that means if it is sorted, then only you would want a first one and the last elements, right? So let me copy this and put this as well into the repository. So demo 2, let's call it as what? First element, and let's not call it as element, let's call it as first entry itself, so that it will be easy for us to remember even the name. First entry, and then poll first entry, right? So it'll be easy for us to remember that. The method names, like we have first entry, we have a last entry as well. Like we have poll first, we have poll last as well. So you can simply test that here. I will perform a poll last for you, or a last entry for you. So only focus on this. Here up to here I have only 3 players created. Okay, so I'll do system.out.println. I'll perform a players dot last. So last entry, since it maintains the order, what was the last player I added? KL Rahul was the last player added, so it should return me that. So that is added, that is retrieved, right? KL Rahul 1 and KL Rahul is retrieved. Looks good. Last entry, similarly we can even do a poll last, right? Poll, what it will do, it is going to retrieve and remove that last entry, whereas last entry will just retrieve you that. Fine. So if I print this map after doing a poll last, we'll have only 2 elements left into it, that will be Rohit and Sachin. So you can print that and see it when you are practicing these things. So let's call it as demo 3, poll first, poll last, last entry. Poll first we have already seen, right? So poll last and last entry. Fine. So let's now talk about the next type of map, which is going to be a tree map in our case. So here I will create a tree map. A tree map, integer string, once again should be a tree map. Let's save it. So what our linked hash map did was, first I will comment out all these things that I have written. Okay, so we'll just iterate over the map and see how it works. Let's let's remove it so that it does not confuse us. All these methods will still be available into tree map as well. So here we have players and a tree map is created. Let's save it. In the previous example, when I was using a linked hash map, at that time the order of insertion was maintained. Now in this case, the order of insertion will not be maintained because it is a tree map, so it should be sorted based on the natural ordering. So let's save it and run this and see whether the ordering is based on the keys or based on the values. Fine. So you can notice that the ordering is based on the keys. Fine. So that's what we got. So what I will do is to ensure that, let's add up an element in here. Let's call it as 17 and ABD, save it, run it. Fine. So you can see that it is ordered based on the key. Fine. So like we have performed this sorting and all in a tree map. If you remember tree set, we know that a comparator can be passed into it, right? So first let me put this into the repository. Let's call it as demo for tree map. So we have seen tree set, we have seen a priority queue which is sorted, and then now we are seeing a tree map. So if I ask you if I want to reverse the order, then what would be your answer? How will I be performing a reverse order sort for this? So obviously when we are taking this tree map, you see that it takes a comparator, and we know that we have a reverse order comparator already created for us by using a collections dot reverse order. So by doing this, the keys will be reversed, right? Keys will be reversed, and it was now in an ascending order, it will go in the descending order. And when we can apply this type of comparator, we can also apply what type of comparator on it? We can also apply our own comparator. If my keys were of type player, then I could have even arranged it as per my comparator. Since I don't have that as for now, so I'll not be using my own comparator. I already have a collections.reverse order comparator created for me, which is sorting this collection in a reverse order. So it's same as what? Same as your tree set or maybe a priority queue. Fine. So let's call it as demo 5 and call this as sorting in tree set, reverse order sorting in a tree set. Fine. So other methods, what you can simply do is you can explore the other methods that are available for us. Okay, so let's close this linked hash map and all that. So what you can simply do is you can go for just a linked hash map or a tree map or anything. It is hash map. Okay, linked hash map. You can go for the official documentation, linked hash map, and you can see the methods that are available into it and use the linked hash map specific methods. How it works, like I told you, hash map is the parent of this linked hash map. So you can go ahead and then see what all specific methods are available. These are the constructors that are available, methods that are available into this. We have seen what method? The first and the last entry, right? So here yeah, last method, first method should be here, collections dot, or else what we can do is we can simply say last method and all. Last entry. So you can search for those methods and then get the description. Last method or last entry or first entry, or maybe a pollFirst and pollLast, all of that will only be available if your map is either ordered or it is sorted, which means either it is a linked hash map or it is a tree map. In other maps you will not see it, that is hash table and a hash map, you will not see those methods. So you can go Google it and check out all the other functionalities also available into your map implementation. Fine. So I think we have already cleared up all four maps, that is the hash table, hash map, linked hash map and the tree map. So these are the four basic implementation of a map interface. Fine. And it does not implement iterable, that's why we don't have an iterator. So for iterating over a map, we either use a keys and the value pair, sorry, a key set or an entry set. Now let's make it a little more complicated by implementing the collections into a collection. Fine. So I hope up to now everything is pretty much clear and straightforward to you. Now what I will do is I will create a little more complicated map which is kind of a real-time use of a map. So what I will do here is I have used a lot of player stuff and all. So what I'm gonna do is my requirement is something like I want to create a map that should store the books and the ISBN number, and I should be able to find a book based on the ISBN number in a library. So I have library and I have books inside the library. So I should be able to find out the book in a library based on the ISBN provided. So that's what I want. So let's go ahead and create the classes required for the same. So I need books. I'll be creating a book class, and the book class would contain private, let's say a string ISBN. So an ISBN number will be there, and then I will create the title for the book so that it should be easy for us to understand which book is that, right? So let's call it as private string title of the book, and maybe I can include more properties here, maybe a author as well. Private string author. So I have a book with three properties, that is the title, ISBN and the author. Okay, so we know that whenever we create the properties, we go for the constructor, the default one, the argument one. So generate the constructor using field, done, so that we can initialize this book the moment we are creating the object of the book. Fine, looks good. And then we want the getters and setters to be generated. So let's generate the getters and setters. That's done. And I also want a toString method to be generated. So I have a toString method generated. Done. Fine. So now what I will do is I'll create a library. Library should be capable of storing the books. Fine. And the library should not only store the books, library should actually allow me to store the books and also find me the books based on the ISBN number provided. So let's create a library instance as well. So I have a class again, library class. There we go. And the library will have private string name of the library. Okay, and the library should contain the books, collection of books. So what will I do now? Library contains the books. The type of books I can decide it now based on the collections that we have studied. So what I want is I want to get the books based on the ISBN provided. So only one such collection we have studied, that is the map collection, right? If I wanted unique books to be stored into a library, I could go for the set. If I want even the duplicate books can be stored into a library, I'll go for a list. And again, if I want the first book entered into the library, added into the library, should be the first book given to the students. In that case, I could go for a queue, right? Again, based on the requirement, I will choose which queue or which set or which list or which map. So in this case, we should be using a map because our requirement clearly says that we want the books to be stored into the library. Also we want a functionality where the details of the book should be retrieved based on the ISBN provided by the user, right? So for that I'm creating a book of type map. Okay, so this is a book of type map. Now the book will have an ISBN, so it is going to be a string, and then the books will be stored into it. So the next type of data is of type book. So in this map, the books, I can keep adding the books, right? So let's save it, and once again generate the constructor, the default one, then again the constructor with arguments, constructor using field, and then I want the getter setters to be created for me. Generate getters and setters. So here we go. I have the getters and setters created, so which will get me all the books and set the books, and the toString method. If I print the library, that prints me the detail. So now in this library I should have a function that allows me to add the book in the library, right? And also I will create a library service class. Library service will have a main method in that. Done. So let's go to the library, and in this library let us allow the user to create the to add the books into the library. Fine. So here inside this itself I'll be creating a map. I'll initialize the map. Whenever a library instance is created, at that time either you provide the map from there, whichever books you want to add into the library, you allow that. Fine. If you're creating this, or if you are not passing in that, then default constructor will be used, and then whenever we are performing a set books, then we have to pass in the map there. Fine. So we know that at this level we have the map, but that is not initialized. That's not that does not have any new keyword and all that into it. Fine. But we know that it is a map, and we can put the book into a map based on the ISBN provided. So I'll be creating a function here that tells me whether the book is successfully added into the library or not. So public, it will take a string, and it will be a add book into the library. So add book, whichever book you want to add this add into the library, you have to provide a book object for that. Okay, so book object will be given to us. I'm returning an empty string as for now. So whenever you are adding a book, that has to be added into the library. So we have created a map, which is what the books dot add, sorry, dot put. So I want to put the book, and the ISBN of this book that is provided should be the key, and the book should be the value. So I'm passing in the book, and the ISBN should be taken from the book itself, book dot get ISBN. So it will take the ISBN and add the book, and if this happens, then say book added to library. Fine. So if not, what I will do is I'll perform a try block and return this. Fine. If at all there is any exception while adding the book, then I will catch it and I'll perform a return cannot add book, right? So let's save it, and I have created a functionality which adds the books into the library as well. So now what we need the books should be added into the library, and we need to perform a search and see whether we can see the books available into the library or not. So we know that again the map has the method for search book and the get and all. So here I will create another method, public book. It will return me a book. Whenever a user gives an ISBN, it has to return a book, right? So public book search book, a string ISBN will be given, and I have to find the book and return that particular book. Once again, what I'll do is I'll just write this, okay, and I'll return null. If null is returned, that means the book is not found. Return null here. or I can throw an exception and catch the exception there. Depends on my requirement. So just because I don't want to make it more complicated, I'm not performing a throws exception and catching the exception there. Okay, so as for now, let it be null if a book is not found. If the book is found, in that case, what we do, we can simply do a books.get based on the ISBN and return the same. So if it returns a book, then that book is available. If it does not return a book, if it is null, then the book is not available. What we can do is we can create a custom exception, book not available. We can throw it with this, and then a user who is calling the search book should call it inside the try and catch block, and then what they should be doing is they have to catch the exception, and then they should check whether the book is available or not. So in this case, what I have done is I have simply searching the book into it. If it throws an exception, it returns as null, and there we can check in the service where if it returns null, then the book is not available. If it returns a book, the book is available. So that way I have created two functions inside this library, one that allows us to add the book, another one that allows us to search for the book. Fine. So let's save it and go to the library service and try and implement the same. So here I'll be creating the book instances. So hopefully you have got to know these things. In a book class, I don't have anything complicated, just the three properties, ISBN, title and author. Okay, and I generated the default constructor, generated the constructor with argument, generated the getters and setters, and generated a toString. So it is very simple. Similarly, library also I did the same thing. I created two properties there. One is the books property, which is of type map, and then the name of the library, which is of type string. Then I generated the default constructor with argument, getter setters for the same. After that, I created two extra functionalities in that. One is to add the book, and whenever I am adding the book, I am taking the book as an argument from the user, and I am adding that book itself into the map, right? Books.get ISBN. So I'll take the ISBN as a key and then the book as a value there, and I'm adding the book. And if the book is added successfully, it says that book added to library. Else it will throw us an exception and it will say cannot add the book. So we have to check what it returns. If it returns book added successfully or not. Okay, then we are searching for the book. A user gives us the ISBN, and based on the ISBN we are searching for the book. If the book is available, we get the book. If not, then we get an exception. So let's go ahead and create the book instances, and then based on that we will try and add the books into the library. So ISBN, which is a string, let me give a string. Let's call it as hash 12 is my ISBN number. Then the title of the book, let's call it as my first World Cup. Okay, and this was actually returned by Pele, but then I will just change the author. My first World Cup, maybe returned by somebody, Virat. So similarly, what I will do is I will create more books. So this is our book 1, book 2, book 3. 3 books I am creating. So let's call it as 13 and 14, my first World Cup, and maybe my life, and someone else as an author, maybe Rohit. And one more book I would like to add, that is Secret to Fitness or something. Another author, the same author itself I am adding. Now I have 3 books. I want to create a library. Let's create a library instance. So you have a library is equal to new library. So while creating the library, I need the name of the library and the books to be added into the library, which is basically a map. So I'll give the library name as MG library, and I need the map to be provided here. I can directly say new map and then perform all the put and everything. But to make it easier, I will create a map for you. The map is of type key, which is string, and the value book. That map itself can be added here, right? The books in the library is equal to new. So let's create a hash map for this, because I don't need the ordering to be maintained, and I don't want to even have sorting into this. So at that time, hash map is best because it will be faster comparing to a linked hash map. Linked hash map would take a bit more memory because the ordering has to be maintained. So for that I will take a hash map. So it again depends on my requirement, whether I want sorted books to be taken, or maybe I want ordered book and all. Depending upon that, I will be choosing a collection. So I have chosen a hash map because it is faster and I am least bothered about the ordering and sorting of the books. Fine. And then I can say books.put. So let's add those books in there, and I will add all the books that are available here, book 1, 2, 3. So I will take the book 1 dot get ISBN of that book, and then the book which is book 1. Similarly, I want to add all 3 books into this 1, 2 and 3. So while initializing itself, I have all the books available into the library. Now the library has 2 functionality. As for now, what I will do is from the libraries I'll just try and get the books, right? So library has something called as the get books, right? Library has the get books that returns us the books available into the library, which is the map, right? It's a map. So iterating over a map has to be performed. That is, we can either use an entry set for it, or we can use a key set for it, right? We have already discussed that in our previous examples, how do we iterate over a map. So we will be doing that in the library service. I want to know the books available into the library, MG library now. So this is the library dot, I want to perform a get books here. So I want to check what all books are available here, and that books actually returns me a map, right? Map of books. So let's call it as books in library. Books in, or let's call it as MG library books is equal to library dot get books. The library is the instance of that MG library itself, right? So I get the books and I want to print all the books that are available for me. So I'll go for a for. Okay, and then we know I want to iterate over this library, that is library dot an entry set for the same. Sorry, library dot get books dot entry set. My library books is already there for me, so I don't need this. So MG library books dot entry set, and it is of type what? Map dot entry. The key is string for my map, and the value is book. So I have that created, and I'll give the instance, let's call it as the books, fine, or let's call it as a book, and then I will simply do a system.out.println here, and I'll print only the values. The value contains everything, right? So the key is ISBN, value contains every detail of the book. So we'll just do a book dot get value. Fine. So that gives me all the books. So let's run it and see whether I get all the books available into the library or not. So it is giving me only the last one. Let's see why is that. So library my books. Oh, I have added all what? Book 1 itself. So I have to add what? Book 2, book 3, and ISBN book 2 and book 3 has to be added. That's why it was giving only 1, because the ISBN was not different, and we know that the key should be unique. That's why it was not added. The books were not added. Now I see that all the books are added into the library. Let's see the functionalities that we have added into the library class. What is that? Adding a new book and retrieving a specific book out of a library. I hope up to here everything is clear to you. What I have done, I have simply created the instance of book. Then here I am creating a map and passing that map to a library book. That means this map will be taken and it will be given to the library constructor. So it comes here to the constructor and it initializes that books to the available books here. That means this books will be equal to the books that we have created here. So all the books will be going into the library. Fine. And then what I did was check what all available books are there in the library, and I am taking that books and I'm iterating over the books and getting the value only. because we know that this map is of type string and book, which is ISBN and the value. So what we have done here, a string ISBN and the value, so that will be added here, which we have done here, right? ISBN and the book. Now what I will do is I'll try and search for a book here. So library dot, I created a search book. This search book takes an ISBN and then allows me or gives me the book. So ISBN of the book is what? #12 is my first World Cup Virat. So I want to check whether that is available or not. 12. This should give me the book, right? So book searched book is equal to, and we know that there we have created when you see this library, when I am searching for the book, I have created with the negative case as well. If you find the book, you get the book. If there is no book, then you get the return statement as null. If searched book not equal to null, then system.out.println, you searched, your book is here plus the book, right, which is the searched book. So that will give me the details. If it is null, then gives you cannot find the book you searched, right? Save it. Let's go ahead and try to find out the book. So your book is here, book is 12, title and the details, because that book is available in the library. If suppose I give it as something like 16 or 17, at that time I get a null, and then I get the message as cannot find the book that you are searching for, right? So here I am directly passing in this search, and the #16 you can allow the user to enter the book that he wants to search using a scanner and then perform all the other operations. So search book is working perfectly fine. Let me also test the add book into the library. So this functionality is search book. So my search book functionality is working very perfectly fine. So I also want to do a add book functionality. So how do I add a new book to the library? So now that this is already done, right? So I want to have a book and I want to add it to the library using a add functionality. So here I have a book. Sorry, I'll not do a book puts and all that. So I'll create a new book, book 4, and I want to add that to the library, and I also want to check whether that particular book is available or not. So here I go and I'll call it as book 4. Okay, 3 books I have already, and I'll give this as 16, and let's call this as new book. Okay, the author, let the author be Virat itself. So I'm adding a new book, and I've just created an instance. So let's see how do we add the book. So library dot, we have a function there, add book, and we have to pass in the book there. So book 4 added, fine. So here also this returns us what, whether the book is added or not. So we either get what, book added, or we get cannot add the book. So that message. So let's run it and see whether the book is added or not. So it says book added to the library. Now just getting a message is not enough. We have to again search and find out if that book is available or not. So what I can simply do is, once again I can perform a searched book, and then I can check whether the book is available or not. Okay, so let's do this again. Search book 1, or let's call it as search book 16. So if search book 16 is not equal to null, then your book search is search book 16, that is the ISBN is what I'm writing in there. So let's save it and check after adding the book whether that book can be searched or not. So after, see, this book 16 was not available here. I added that book 16 here, which says book added to the library. Now that book 16 is retrieved to me. So this way you can create collections of type object as well, and collection within the collection as well. And in this example we have used a real-time use of a library and the book. Library containing the books. So because the library contains multiple books, I have created a collection for that. So still my collection is just of type string and of type object. I can have a collection that is of type string and books. That means I can search for a library name and find out all the books available into the library as well. Maybe in my next example I'll be showing you that, but as for now, I hope this is enough, and this is a real world use of the concept of collections into Java. Hope you are enjoying the collection stuff. If there is any doubt that you have, you can always ask me the doubt. So what I will do is I'll share all my code with you. So let's go here and add the details. This is my demo 6 library book demo. So here is the book details that I have, and then I created a library class, and then lastly the library service. And if there is any doubt in the things that we have discussed, you can always comment on the videos, or you can reach out to me on LinkedIn and ask about your doubts. Your doubts gets clarified. So I'll try to maximum possible. I'll try to respond to you, because if I get a lot of requests, then it will be hard for me to respond, but still I'll be responding to every single query that I get, because still there are not much subscribers for this particular channel. So what you guys do is, to help me reach out to a larger audience, you share these videos, like and comment if you are liking in the series. Help your students also to get a job. So the series is completely free. There's no hidden agenda behind the series, wherein after some time I'll ask you to pay for the series to continue and all. So there is no hidden agenda at all. So till the series ends, it will completely be freely available on YouTube. So see you in the next video. Thank you.